Rules are useful, important, and complex. If we could deal more effectively with that complexity, we could improve how we choose, write, and use rules. A is a policy expert. They want to design a policy to help people. They need to know whether the policy works as intended. They might use a computer simulation to help. B is a legislative drafter. They want to draft a clear, effective law that implements the policy. They need to know if their draft does what the policy experts intended. C is in IT. They want to change government software to implement the new policy. They need to know how to make their software follow the new rule. D is in compliance. They want to change their company's systems to be compliant with the new rule. They need to know what part of their systems to change, and how. A, B, C, and D all need to interact with the rules in different ways. But they usually don't interact with each other. There is duplication of effort, and no shared digital resources. Interpretations vary, and it is difficult to know whether automated systems are accurately following any particular interpretation. Let's imagine a world in which the rules are not only used by people, but can also be read and used by automated systems. That would require both the rules we have, and a digital encoding of their meaning. This digital version would be developed collaboratively, ideally when the rule is written. It would be isolated, describing only the rules themselves, and as much of the rules as possible. It would be reusable for many different purposes. It would be authoritative, because the drafters and policy experts are involved in its development. And it would be trustworthy, because it would be shared publicly. In this world, policy experts could use simulations more easily, getting better information about how proposed and actual rules behave. Drafters could use the encoding to test their drafts for loopholes, detect unintentional ambiguities before they are enacted, and use simulations to communicate more effectively about drafting instructions. IT staff can use the shared encoding to power or test systems that need to implement the rules. Compliance professionals can use the same software to power or test their internal systems that the regulator uses themselves. Interpretations are consistent, and we can be more confident that our systems are legally compliant. That is the idea behind rules as code. Let's digitize rules, collaboratively, as early as possible. And let's use the digital version to get better at choosing, writing, and following rules. Rules as code is a relatively new idea. It will require new tools that can be used by programmers, lawyers, policy experts, and others. Blawx is a prototype designed to show that interdisciplinary tools for rules as code can be both easy and powerful. Using Blawx starts with entering the text of your rule. The sections and subsections of your rule become the organizational structure for your code. If you need to divide the text more precisely, you can give names to selections of the text. Next, you encode the sections of your rule, one at a time. The code editor uses a friendly drag-and-drop interface, based on Google's Blockly library, which is often used to teach coding to school-age children. The code is easy to read, even for people who don't know how to write it. This allows technical experts and rule experts to work together, on the same encoding. Rules are encoded as rules. Unlike other tools, in Blawx you do not need to reformulate rules into a decision tree, or an algorithm. You just translate the rules themselves. For each section of the rule, there are two things to encode. First, you describe for Blawx the vocabulary being used in that section that the encoding doesn't already know about. In this example, the legal knowledge engineer explains that there is a category called person, and how to describe the idea a person may or may not have been a pensioner. Second, you encode the rules in that section, or the logical implications that arise. In this example, the legal knowledge engineer explains that if a person is a pensioner, they are qualified under the current section. Blawx's vocabulary is built using categories. Objects belong to the categories. Attributes of the objects hold values. Values can be true or false, numbers, dates, durations, or references to other objects. Rules are often written with exceptions, which can make it more difficult to translate your rules into code in other tools. Blawx understands exceptions, and allows you to encode them as and where they appear. You simply refer to the sections in the rule, and say which overrides the other when they contradict each other. Once your rules are encoded, you can ask questions and get answers. These questions are called tests in Blawx, and are written using the same code editing interface. Tests are useful for ensuring your code works as expected, for ensuring the rules have the desired policy effects, for finding drafting errors, and for helping people understand how the rules behave. Test can be true-false, or searches. In this example, Blawx is asked to search for people who qualify for a benefit. Blawx's most recent feature is the scenario editor. The scenario editor allows a user to run a test against a fact scenario that they describe in an automatically generated web interface. In addition to describing what you know, Scenario Editor allows you to describe what you do not know by unlocking certain facts. In this example, we use the Scenario Editor to create a fact scenario in which there are two people, Adam and Bob. Adam was a pensioner in July of 1977. Bob was born in 1950, has lived in the country for 40 years, and is a citizen, but we don't know if he was a pensioner in 1977 or not. When you run a test in the Scenario Editor, it asks the Blawx reasoner to answer the question in the context of those facts, and display the answers. The Blawx reasoner is powered by a cutting-edge symbolic artificial intelligence reasoner, which gives it a number of powerful capabilities. First, Blawx will return all of the answers that it can justify. In this case, there are ways of deriving that both Adam and Bob are entitled to a benefit. Second, Blawx explains its answers in natural language, with reference to the text of the rules that were used in its reasoning. This is very useful both in development, for ensuring that the code is giving the right answer for the right reason, and in deployment, where explainable automated decision-making is increasingly critical to public trust, ethics, and regulatory compliance. Third, Blawx does not generate only one explanation, but may find multiple justifications for the same answer. Here, there are two different reasons Bob is entitled to a benefit. Fourth, Blawx can reason in the context of uncertainty. We said in the Scenario Editor that we don't know if Bob was a pensioner. The reasoner has concluded that there are two ways Bob might be entitled to the benefit. In the first way, Blawx presumes that he is a pensioner, and qualifies under Section 3(1)(a). In the second way, Blawx presumes that he is not a pensioner, and he qualifies under Section 3(1)(c). The Blawx reasoner also knows that whether or not Bob is a pensioner is relevant for finding answers that do not rely on assumptions, and so it highlights it as a relevant fact in the Scenario Editor. This ability to find relevant inputs can be used to ensure legal expert systems based on Blawx encodings pose only relevant questions to users. Sometimes you will ask a question for which the Blawx reasoner can't find any answers, and you were expecting it to find a particular answer. In most tools, discovering why requires a complicated debugging process. The final unique feature of the Blawx reasoner is that unlike most tools, Blawx is just as capable of explaining why something is not true. To troubleshoot, you can edit the test to add the "not" block to your question. Running the test again with the same facts, you get all the possible explanations. The last explanation is closest to the reasoning we expected, and by reviewing it we can see that Blawx thinks that Bob does not qualify because he failed to meet the test in Section 4, and so the exception in Section 4 applied to him. When your code is complete, you can make the code and tests publicly readable, and the Scenario Editor publicly usable, by setting your project to published in Blawx. This also makes all of the project's tests available over a web API, for integration with other software. A live demonstration of Blawx, including the code used in this video, is available at dev.blawx.com. Blawx is open source, distributed under the MIT license, and deployable as a Docker container.